All right, we're going to take a couple looks at this data set here. First, on the first slide, what we're going to look at is without the calculator. What could you determine about this without a calculator? So first, could you determine the function model? And if so, how would you determine the function model? Meaning, is it quadratic? Is it linear? Is it cubic? Is it rational? How could we determine what type of function model this is? Start with AROC. Very good. If you're ever doing a non-calculator problem and you're given a table, start with AROC. First, what are we changing x's by every time? 1. Okay, because remember, what is the formula for AROC? So change of y over change of x. We are changing x's each time by 1. And you don't actually have to do the positive on x because it should always be increasing. So I don't have to list out the dividing by the change of x, but I do need to write down what my y's are. So this would be, how much by increasing by? 6. Well, I'll do it one time. You divide that by 1 and we would get positive 6. Okay, what about here? 32? I'll do it one more time, then I'll stop dividing by 1. That's AROC of 32, average rate of change on that interval of 32. What about here? A little bit bigger number. Not 89. We were really close. Not 99. 88. It's 88. There you go. 88. Okay, how about this one? 174. And lastly, 290. Okay, you know what we can absolutely state that this function is not? I know it's not linear. How can I know it's not linear? Because the AROC is not constant. Okay, now, if it's not constant there, you find the next column, which would be titled change of AROC. Let's now do the change of AROC. The change of AROC. Here we go. Change of AROC. How much do I change going from 6 to 32? 26. Let me do a plus, sorry. 26. How about from 32 to 88? $56 is correct. How about from 88 to 174? 86. And now how about from here to there? 116. Okay, now you know what else I can state? Not only is this not linear, the blue, we realize that this column is not linear. We realize this is not linear because this was not constant. This was not constant, so that was not linear. You know what we can now say? Is this one constant? If this is not constant here, if that's not constant, you know what this is not? I need someone to say linear.
It's linear.
It's not linear. You know what that means? This one's not? It's not quadratic either. Make sense? Okay, this one we need to do one more time and we'll come up with our solution here. If I did one more column, you could call it the change of AROC, but I'm just going to leave it as is. This is our third change. What is the change from 26 to 56? 30. What about here? 30. And finally here? 30. Okay, I can see that this is constant. That these values are constant. They're 30. So what does that mean is true about the red column? These could be expressed by a linear equation. A linear equation could find all those values. That would be 30x plus whatever. This column, I didn't mean to go red. Sorry, let me write this in green. This one we now can say is linear, which means the AROC column would be found by a quadratic expression. And that would mean the actual function itself is cubic. This is a cubic function. Just to be clear, y is a cubic function. I'm going to slide that down. Y is a cubic function. Okay, let's just go ahead and fill this out. What function model best describes AROC? That would be a quadratic. AROC. Oops. AROC is quadratic. And delta AROC would be linear. The delta AROC would be linear. Now here's a question for us. How could we describe the concavity of the function y on the intervals from 0 to 5? Is it concave up or concave down? Let's determine. Wait, how can you determine concavity? What do you look at? Remember, you don't look for concavity, you look for one of two other things. What are the things you can look for? You look for if this is increasing or decreasing. And what is it doing? This is increasing. If this column is increasing, what does it mean is true? If AROC is increasing, what has to be true of y? Concave up. This has to be concave up. Another thing you could do is you could look at delta AROC, the next column, and if this one is positive, if this column is positive, then that means this one has to be increasing, which means this one has to be concave up. So we would say this is concave up on that interval. Any questions about how to do that without a calculator? So those are just as a review, some of the things you need to know how to do without a calculator. With a calculator, if you go to your next one, we're going to look with a calculator. Same data. So we already know what type of function is this. What type of function is it? Cubic. Go to your calculator. Let's go over what we went over last class. 1-13. Let's go over this. If you remember, once you have your Desmos fired up, hit the plus, choose table, or you can just type in table, whichever is easier for you. Let's type these values in.